This is an example from section 13.6 in MGF 1106 dealing with an application of the normal distribution. In this problem, it says we do have a normal distribution of the amount of coffee that is dispensed into an 8-ounce cup, and we know that we do have a normal distribution, and the mean of that normal distribution is 7.5 fluid ounces. So we'll label our normal curve and put a mean of 7.5 ounces in the middle. And it says if the standard deviation of the amount of coffee dispensed is 0.4 ounces, and again we have a normal distribution, the question is find the percent of times the machine will dispense between 7.3 to 7.8 fluid ounces. So again, we have a normal distribution which has a mean of 7.5, and we're trying to find the percent of times the machine dispenses between 7.3 and 7.8 ounces. Well, since 7.3 is less than the mean of 7.5, we go to the left of 7.5 and label x is equal to 7.3. And 7.8 would be to the right of 7.5. So to the right of 7.5, so there's x of 7.8. And we want to find the percent of times the machine will dispense in between those two values. So the desired area to find is the amount of area under the curve between 7.3 and 7.8. So we first find that area using the normal curve, and then we can convert that to a percent by timesing it by 100. Now, in order to find area under the normal curve, we're going to have to use the standard normal table. In order to use the normal table, which I do have two snippets of it below, we need to calculate z-scores. Recall, to calculate z-scores, z is equal to the piece of data x minus the mean x bar divided by the value of the standard deviation s. So we need to calculate the z-score for the value of x of 7.3 and the z-score for the value of x of 7.8. Recall from our study of z-scores, the mean has a z-score of 0. So this mean of 7.5, that has a z-score of 0, which is not critically important in this problem. But values that are less than the mean, such as 7.3, would have negative z-scores, and values that are above the mean or greater than the mean would have z-scores that are positive. So when we calculate the z-score for 7.8, we're going to use the z-score formula there, the standard score formula. We go 7.8 minus the mean of 7.5 divided by the standard deviation that was given at 0.4. If you subtract, you get 0.3 divided by 0.4, you get a positive 0.75. So I'll write that right underneath 7.8. have a z-score of 0.75. I always like to keep my x's and my z's below the horizontal line and my areas and percents above the horizontal line. So to calculate the z-score of 7.3, we go x, which is in this case 7.3, subtract the mean of 7.5, and divide it by the standard deviation, it's 4/10. And as anticipated, you would get a negative 0.2 divided by 0.4, so it's a negative 0.5. And we knew values less than the mean would have negative z-scores, and this one does. Now, in order to find the shaded area, we're first going to look up the z-score to the right of z is equal to 0.75. That will be on the bottom snippet that I have there. So we go to where z's in the first column. I've labeled it already. So go to where z is equal to 0.7, 7/10. And then since we want 5/100ths, we have to go over 6 columns. Because the first column would be when we have 0/100ths. So we go to 100ths, 200ths, 300ths, 400ths, 500ths, and go down to the row that has 0.705, 0.7, and there's our 05. So if you look up the z-score of 0.75, it has an area of 0.7734. Recall the table in this course will give us the cumulative area all the way from the left to whatever z-score that we looked at. So 0.7734 is not just the area that's shaded, but it's all the area to the left of that z-score of 0.75. So I'll draw a little arrow. So all of this area to the left is, I'll write it up here, 0.7734. But we don't want all that area because it's not all shaded. To the left of a negative 0.5 over here, under the curve, it's not shaded. So we don't want that area. So we're going to find that area, and we're going to subtract that from 0.7734, and then we'll convert it to a percent. Now to find the area over here in the tail to the left, we have to look up the corresponding z-score, which is a negative 0.5. And that's negative 0.50. There's a 0 after that 5, which means that will be in the negative 0.5 row and in that first column there. So 0.3085, that's the unshaded area, 0.3085. So that's the area we do not want because it's not between 7.3 and 7.8 ounces. So we take our calculator, we go 0.7734 minus 0.3085, and we'll get 0.4649. And that is this area in between, 0.4649. That's the area under the curve from 7.3 to 7.8 ounces. Now, since the question said find the percent of times the machine will dispense between those two values, we have to convert our decimal, or our area, into a percent by timesing it by 100%. Thus, our overall final answer would be 46.49%. Which is a little bit less than 50% of the time our cup would have between 7.3 and 7.8 fluid ounces of coffee in it.